The Earth is a place of constant change, a swirling mix of vibrant life and complex systems. Sometimes these changes bring good news, offering glimmers of hope. Other times they remind us of the consequences of our actions. Recently, two events, one in Africa and one in space, have captured our attention. They highlight the unexpected turns in our relationship with nature and technology. The first event brought optimism for conservationists. Rhino populations are showing resilience. Advanced survey methods and anti-poaching efforts revealed larger-than-expected numbers. In contrast, the second event was a fiery reminder of our technological progress. An aging space lab made an uncontrolled re-entry into Earth's atmosphere. This event highlighted the growing problem of space debris and the need for responsible management. The plight of the rhinoceros has long been a somber tale in the fight against extinction. Hunted relentlessly for their horns, their numbers have dwindled drastically over the past century. Yet, amidst the bleak statistics, a beacon of hope has emerged. Recent surveys employing cutting-edge technology have revealed that certain rhino populations are larger than previously estimated. This discovery, while cautiously celebrated, signifies a turning point in rhino conservation efforts. The reasons behind this resurgence are multifaceted, a testament to the dedication of conservationists and the impact of well-implemented strategies. Anti-poaching patrols, often working in dangerous conditions, have played a crucial role in deterring poachers and dismantling illegal wildlife trade networks. Moreover, the expansion of protected areas and wildlife corridors has provided rhinos with safe havens to roam and reproduce. These efforts, combined with growing awareness and support from local communities, are slowly turning the tide in favor of rhino survival. The success story of the rhino serves as a powerful reminder that even in the face of seemingly insurmountable challenges, persistence and collaborative action can yield positive results. The recent rhino population estimates highlight a crucial aspect of modern conservation: the role of technology in monitoring and protecting wildlife. Traditional survey methods, often relying on ground patrols and aerial observations from manned aircraft, can be time-consuming, costly, and limited in their scope. However, the advent of drones and satellite imaging has revolutionized the way we monitor and manage wildlife populations. Drones, equipped with high-resolution cameras and advanced sensors, can access remote areas with ease, providing real-time data on animal movements, behavior, and population dynamics. Meanwhile, satellites orbiting hundreds of miles above Earth capture vast swaths of land, allowing researchers to track changes in habitat, identify poaching hotspots, and monitor wildlife populations across entire ecosystems. This wealth of information, analyzed using sophisticated software and artificial intelligence, provides conservationists with unprecedented insights into the lives of endangered species. It enables them to make informed decisions regarding habitat management, anti-poaching strategies, and conservation priorities, ultimately increasing the effectiveness of their efforts. While the rhino population offered a glimmer of hope, the uncontrolled re-entry of an aging space laboratory into Earth's atmosphere served as a stark reminder of the challenges we face in managing our technological footprint. The lab, a testament to human ingenuity and scientific exploration, met its fiery demise as it plunged through the atmosphere, breaking apart into a shower of debris. This event, while visually captivating, highlighted the inherent risks associated with objects re-entering Earth's atmosphere. As these objects travel at incredibly high speeds, friction with the atmosphere generates intense heat, causing them to burn up. However, depending on their size, design, and materials, some components may survive the fiery descent, potentially posing a threat to populated areas. While the likelihood of debris from such events causing significant damage or harm is statistically low, it is not non-existent. The uncontrolled re-entry of the Space Lab underscores the importance of responsible space traffic management and the need for international cooperation in addressing the growing issue of space debris. Section 5. The Perils of Re-entry. Understanding the risks. The re-entry of objects from space, whether controlled or uncontrolled, is a complex and potentially hazardous process. As objects descend through Earth's atmosphere, they encounter increasing air density, leading to intense aerodynamic heating and drag. This can cause them to break apart, with fragments scattering over a wide area. The risks associated with re-entry depend on several factors, including the size, shape, material composition, and trajectory of the object. Large, dense objects, such as satellites and rocket boosters, pose a greater risk than smaller, lighter objects, which are more likely to burn up completely. Objects made of materials with high melting points, such as titanium and stainless steel, are more likely to survive re-entry than those made of aluminum or other lightweight materials. While most re-entering debris falls into the ocean or uninhabited areas, there is always a chance that fragments could land in populated regions, potentially causing damage to property, or in rare cases, harm to individuals. This underscores the need for robust tracking systems, accurate re-entry predictions, and mitigation strategies to minimize the risks associated with objects returning from space. Section 6. Space junk, a growing concern. The uncontrolled re-entry of the Space Lab brought to the forefront a growing concern: the proliferation of space debris orbiting our planet. Every satellite launch, every rocket stage left adrift, every collision between objects in space contributes to a growing cloud of debris that poses a significant threat to our continued use of space. This debris, ranging in size from tiny flecks of paint to defunct satellites and spent rocket stages, travels at incredibly high speeds, posing a collision hazard to operational satellites, spacecraft, and even the International Space Station. Even small pieces of debris can cause significant damage upon impact, potentially crippling critical infrastructure and jeopardizing human spaceflight. The consequences of a major collision in space could be catastrophic, potentially triggering a chain reaction of collisions that could render entire orbital regions unusable for generations. This phenomenon, known as the Kessler syndrome, highlights the urgent need for proactive measures to address the growing problem of space debris and ensure the long-term sustainability of our activities in space. Section 7. Orbital congestion, the need for sustainable space traffic. As the number of satellites and other objects in orbit continues to grow, so too does the urgency of implementing sustainable space traffic management practices. Just as we have rules and regulations governing air traffic and maritime navigation, we need a comprehensive framework for managing our activities in space to prevent collisions, reduce debris generation, and ensure the responsible use of this shared resource. This framework should encompass a range of measures, including international cooperation and agreements, improved tracking and monitoring systems, debris mitigation technologies, and the development of guidelines for end-of-life disposal of space objects. By adopting a proactive and collaborative approach to space traffic management, we can ensure the long-term sustainability of our space activities while minimizing the risks posed by space debris to both human endeavors and the space environment itself. The increasing congestion in Earth's orbit underscores the need for a paradigm shift in how we approach space exploration and utilization. We must move away from the launch and leave mentality of the past and embrace a more sustainable approach that prioritizes the long-term health and accessibility of space for future generations. Section 8. Protecting our planet, on Earth and beyond. The seemingly disparate events of the rebounding rhino population and the uncontrolled re-entry of the Space Lab offer valuable lessons about our relationship with our planet and the impact of our actions, both on Earth and beyond. They highlight the interconnectedness of our world, demonstrating that our actions, whether on land, in the air, or in space, have far-reaching consequences. The success story of the rhino reminds us of the power of collective action and the importance of investing in conservation efforts to protect our planet's biodiversity. It underscores that even in the face of daunting challenges, we can make a difference when we work together towards a common goal. Conversely, the uncontrolled re-entry of the Space Lab serves as a stark reminder of the potential consequences of our technological progress if not managed responsibly. It highlights the need for proactive measures to address the growing problem of space debris and ensure the long-term sustainability of our activities in space. Section 9. A Shared Future. Lessons from Rhinos and Rocket Science. The stories of the Rhino and the Space Lab converge on a crucial point: the need for a balanced and sustainable approach to our planet and technologies. We are caretakers of Earth, preserving its ecosystems and ensuring well-being for all inhabitants. Facing challenges like climate change and resource depletion, we must learn from our successes and mistakes. The resilience of the rhino inspires us to protect endangered species and biodiversity, The Space Lab's demise cautions us about technological progress without responsible management. We must prioritize sustainable practices in all endeavors, ensuring a healthy future for humanity and our planet. The stories of the Rhino and the Space Lab are about our choices and legacy. They challenge us to act as responsible stewards of our planet, recognizing our actions today shape the world for future generations.